Welcome back. Now we're slowly building out the functionality of our Food Vision Mini demo. In the last video, we created this examples directory with example images. Now let's get our model in there. So let's write moving our trained EffNetB2 model to our Food Vision Mini demo directory. You might have already given this a go, and if you have, I applaud you. But let's now do it together. So what I might do for this one is import shutil, and I'm going to create a source path for our target model. Now we can get this source path from back up here where we saved our EffNetB2 model. So where was that? Saving it here. So this is our best performing model in terms of our criteria. So good test performance, but as well faster latency than our feature extractor on the CPU. So I'm going to create a file path here, EffNetB2 Food Vision Mini model path. Bit of a mouthful, that name, but there we go. Okay, now let's create a destination path for it. Create a destination path. Where do we want to move it for our target model? So we want to move our EffNetB2 Food Vision Mini model destination. What should our model destination be? We want to move it into this directory here. So let's set that equal to Food Vision Mini demo path slash, which is this file here, that's a demo path, slash EffNetB2 Food Vision Mini model path. And we're going to split that on this and get that. Let's see what this looks like, hey? Wonderful. Now, why do we split this? So let's just see what this looks like. So truly, we didn't even have to do that. And if we get this, so all we're doing with that line is removing models slash. So this is where it currently lives, and this is where we'd like it to live. So this is where we'd like our model to move to. So that's why we've created this path here. Again, we're trying to do things as much as possible with code rather than just hard copying things. So let's try to move the model file. And if we can move it, we want to move it. But if it has already been moved, we want to say, hey, it's already been moved. So let's go here, try, and then we're going to print a little info string and go attempting to move EffNetB2 Food Vision Mini model path. And then we want to move it to the destination. So I'm just going to copy in this destination here. Wonderful. And then if we can move it, we want to move it. So move the model, shutil.move. We need a source. So where are we trying to move something from? So it's this path here. We want to move it from this source to this destination, which is our destination path. Which is, of course, what does that look like? There we go. Demos, Food Vision Mini, that's our model path. So that's what we're trying to do. Now, if we succeed in doing that, let's print out an info tag. Info model move complete. Now, of course, we could, as I said, we could just drag and drop our model file. Models, we could just drag that into there. But I want to do this all with code so that we could run the whole notebook again and it all works. So if the model has already been moved, check if it exists. So let's go accept and then print info tag. I need to make a shortcut on my keyboard for the info tag. No model found at EffNetB2. So this is the source. So if it's been moved from the source, we want to just print out this message. If there's no model found at the source, perhaps it's already been moved. And then the next line, we want to check if it exists. So model exists at, and then the destination, we want to check, does it exist at the destination? Oh, excuse me. I just want to get this. Model exists at the destination. And then we can pass that in, dot exists. Wonderful. So you ready? A whole bunch of try and accept code, but once we step through it, it makes a bit of sense. So it makes sense to me. So we have a source path for the model and a destination path. And we want to try and move the model using shutil, move from the source to the destination. And if the model gets moved, we say model move complete. But if there's no model found at the source, we want to then later check and say, hey, maybe it's already been moved. And then if there's still no model found at the source, we want to say, does it exist at where we're trying to move it to? And if it does, we want to print out true or false. So let's see this in action in 3, 2, 1. Oh, we might see this model disappear into here. That's our ideal workflow. Oh, this hasn't refreshed yet. Let's refresh. What happens? There we go. It moved up into there. So we did that. Now, if we run this again, it's not going to do anything. It's going to say, attempting to move model this, no model found there, model exists at this file path, demos, Food Vision Mini, pre-trained model, yep, PTH, true, wonderful. Okay, so now we could replicate this move with code if we came back to this notebook later on. So we are one by one filling out this Food Vision Mini demo. So what should we do next? Well, we just moved our trained model state dictionary file. How about we create model.py? Now, model.py is going to need to have the functionality of our EffNetB2 model function, or create EffNetB2 model. So you might want to give that a shot. Save this code functionality into a Python script called model.py inside Food Vision Mini. Now, if you'd like some help with that, you might want to refer to PyTorch Going Modular on how you can save a code cell to a file. So give that a shot, and then in the next video, let's create model.py to load and create an instance for our EffNetB2 model. I'll see you there.